Well, we'll start today with 2.8 multiplying and dividing mixed numbers. We got three objectives. I can change mixed numbers to improper fractions. And also I can change improper fractions into mixed numbers, which both of these are important when working and operating with mixed numbers, not just with multiplication and division, but in Module 2B, it will be important for addition and subtraction too. But if we can do that, then we should be able to multiply and divide with mixed numbers, because as it turns out, in this class, we never actually multiply or divide with mixed numbers. What we do is we're going to operate with the improper fractions instead, which is why we have to change the mixed numbers into improper fractions first. And then in the end, if we still have an improper fraction, we'll change it back into a mixed number for credit. So going back, we've already seen this before, is we got cycle method here. And remember, this is how many whole pizzas you'd have, or sandwiches. Pizzas, we'll stick with pizzas on this one, but if you have this many pizzas and they're all cut up into this many pieces, then you'd multiply these two to figure out how many pieces that number of pizzas have, full pizzas, and then we add this numerator because the numerator tells us how many extra pieces are in the pizza that's not full, it's not complete. So once we add those together, then we will have a new numerator, but as we've already seen before, the denominator, which in this is showing the letter C, it's just any number. The denominator will stay whatever number this is. And of course, once we do our operations, we'll always check to see if answers can be simplified. We don't necessarily have to do it with cycle method, but it may be helpful as well. So, cycle method, again, we're going to start both multiplication and division. We're going to start with mixed numbers. What we need to do to operate with them is to change those into improper fractions. So this is really just a quick review of stuff that we've already seen. We are going to be doing it in all the problems that have mixed numbers. So just, be ready for that. Yeah, and this one is just another old type of example. Can we change this mixed number to an improper fraction? Because, again, this will be our first step in operating with mixed numbers. So we take a look at that 2/7 right there, and I would use some cycle method. Now, you can start like I'm doing right here. You could say, well, I already see that the denominator here is 8. So I know that my denominator for the improper fraction is going to be 8 as well. And we'll also need to remember with cycle method that we're not actually changing the amount of pizza that you have. So if you have this much pizza, the mixed number should still represent the same amount of pizza in the end. So we'll say first, 2 times 8, right? So this is our cycle method right there.
16.
Yep, 2 times 8 is 16. And then to finish off the cycle, you would add the numerator, so we'll add the 7. That will give us a new numerator for the improper fraction, rather. 6 plus 7, 13. We'll carry the 1. And then the 1 plus the 1 there is 2. So if you had 2 pizzas and you had another pizza that had only 7 of the 8 pieces, but these two pizzas were cut into 8th size pieces, then you would end up with 23 total pieces of pizza that are 8th size pieces. So again, it's the same amount of pizza, just shown in a different way. And we've talked about this pretty extensively. What do you want it to be? Well, in this case, for today's lesson, when we're operating with mixed numbers like this, we need the mixed number to be as an improper fraction in order for us to operate. Now, I'm saying that, but the truth is that you don't actually need to do this. But to do it otherwise, I would say wait till you get more experience before you start looking at those methods. So changing improper fractions to mixed numbers, we've already seen this. And again, this would be for the end. At the end of the problem, when operating with mixed numbers, even with multiplication and division, you still may end up with an improper fraction. But they'll say, in order for you to get credit on this, you have to show it as a mixed number. So we've seen that before. The mixed number format, right? You'll start with kind of like this big box right here, and then you'll have another box here, the numerator, and then you'll have another one, the denominator, like this. That's our mixed number format. And then we're pretty much just filling in the boxes right here for our mixed number format. So you take the two numbers from the improper fraction and you divide the two. So remember, if we were to see just a regular old-fashioned fraction like this one, it is the numerator divided by the denominator. So if we looked at it the same as we have been doing, this is a B over C kind of business, then the division line would be, this would be B divided by C in long division. And then what they're saying is your quotient, the number that's here in long division, is your whole number. The remainder is the numerator, and of course the denominator will not change between the formats. Okay, so it is a change of format, but it is not a change of value on these, which is important to remember. Yeah, there we go. We'll get plenty of experience with this today, and then in the assignment you'll get plenty of experience with it too. But again, probably not enough to say I'm just going to work directly with the mixed numbers, unless you already feel like you do, and that may be true. So let's do this one, and again, we'll get plenty of experience with the regular examples, but let's just take a look at this. In fact, let's just read it as it is. This is 47 over 4 as a fraction, but in reality, it's really a division problem, which hopefully you remember that. It's really 47 divided by 4, like this. Okay, so with long division, we would pretty much cover up that 7 right there, right? Just look at the tens place value. We work from left to right in long division. And we would say, well, how many 4s, these 4s go into this 4? 4, how many 4s go into 4?
1, I guess.
Yeah, there's only 1. So this 1 4 right here means we used up 4 10s really. So we'll say we used up these 4 10s, and when we get rid of those, since we used them, we're subtracting. That means we had no 10s left over, and we know we're in the tens place value because we covered up the ones place value. But those 7 1s are still there, so we're going to have to acknowledge them, right? We're going to drop that 7, and we'll say now we're dealing with the 4 and the 7, so how many 4s go into 7? As it turns out, it's another 1. Okay, so for 1s, I used up 1, 4. 1 times 4 means that we used up 4 of these, 7, and that would give us a remainder of 3. So we're still going to keep the remainders for now. Remember, the decimals come in a future module, which we're not so concerned about right now. So this is our answer. 47 fourths is the same. And again, I'm going to show the fractional part because I just want to fill in the denominator. That is not going to change. But we had 11 as our quotient, and the remainder of 3 is the numerator. Again, this improper fraction and this mixed number have exactly the same value. But we wanted the mixed number as our answer, not the improper fraction. Now you'll keep in mind on exams and the assignment, usually if they don't specify, hey, we need this in a mixed number, I would not do this step. Right? Because this step right here, look at, this wasn't even that much work. And I'm speaking from my own experience. This is enough work for me to make a mistake. Right? Well, what do we do? 1, 2, 3 parts here, pretty much. 4 if you include the subtraction. That's plenty of work to make a small error, which you've seen me do many times. So if we don't have to do this, I wouldn't. And on an exam, they may say just multiply or divide, and then you just do that. You don't really need the mixed number answer. But you will need to operate with the improper fractions. So what we did before in changing the mixed number into its improper fraction format, yeah, that's definitely going to be something you'll have to do, okay? So with that review then, this is just another review of cross simplification, which we will need to do when operating with mixed numbers. But once again, there's the step before any of this stuff. And again, this is just a focus on multiplication. Remember, later on in this lesson, we're going to get into division with mixed numbers. But like fractions, we never actually divide with mixed numbers. We only multiply by changing the operation to multiplication and then flipping the second fraction. So if that keep, change, flip stuff works for you, then that's what you're going to do, or however you want to memorize that stuff. But this cross simplification, right? Again, this is just saying, well, look, I can divide this number and this number by the same number. So they're both divisible by the same number, and pretty much they cancel out. And then over here, if you wanted to cancel out this way, you can as well. So these are diagonal crossing or cross simplifications here for both of these. But like we saw on the starter problem, though, it is possible to simplify up and down directly, just like you would with a regular old-fashioned fraction, like if you're simplifying it. I think we've seen this before because we saw it last time with the multiplication and division, which were separate lessons. But now that we have some experience in our belt with those, this is the same slide. We've seen this slide already. Well, maybe we haven't because of the mixed numbers. But change all the mixed numbers into improper fractions. That's the first thing you're going to do. Then you're going to do the operation. Notice this is not saying that it's specifically multiplication or division, because in the next module, it's going to also include addition and subtraction. But for today, in this unit, we're just going to stick with multiplication and division. And then change answers back to mixed numbers. It says if it's necessary. Like I said, I wouldn't do that unless they're going to force me to do it, because I don't want to do that extra work and open myself up to making small mistakes. So we got 2 1/10, and then we got 6 2/3. If you're looking at this and you're like, what operation is being performed? Well, the operation is not being shown, and the only operation we don't have to show all the time is multiplication. So we definitely know we're dealing with multiplication, and if you still weren't sure, it does say multiply. So there you go. But the first thing we're going to need to do is take both fractions. Let's start with the 2 1/10. Now, because it's nice to just focus on one part at a time, I'm not even going to look at the 6 2/3. Don't worry about that right now, okay? Focus on one part at a time, and then once you get that part done, then go to the next part. So I would look at the 2 1/10, and I'd say, hey, this 2 1/10 right here, I'll use red. I know it's going to stay in tenths, but I need the 2 1/10 as its improper fraction. So I do need a new denominator. And for that, I'm going to use my cycle method here. So first I would start with 2 times 10. And this is nice because it is in our multiplication tables, which hopefully we have memorized. So that would give us 20 pieces of pizza. Then we add the extra 1 piece. And that would show us that in 10th size pieces of pizza, we have 21 pieces. So that's our new improper fraction right there from the 2 1/10. Now that I have that, of course, I can't do anything more with it. So I do need to look at the 6 2/3. And if you were like, well, actually, maybe it'd be good to cover that other stuff up, then feel free to do that. I'll keep that there just in case it does distract us. But I'm also going to use a different color for 6 2/3. So the 6 2/3, I'm going to drop it, and the denominator is not going to change. So if this one's in thirds as it is, then this improper fraction format is also going to keep the denominator in thirds. But what I need is cycle method. So I've got first 6 times 3, which is 18. And then I'll swing this back up and add those extra 2 pieces from the numerator, which would give me 20 pieces that are all third size pieces. Now at this point, if you wanted to put some parentheses like they were using before, feel free to do that. If you're like, I just want to use a multiplication symbol at this point, that's fine. Maybe you don't even need the multiplication symbol or the parentheses. You're like, I already know what I'm doing on this stuff, so I don't really need it. That's fine too. But it, just may be helpful to see it. But this is our problem now. In fact, what we could have done, and now that we have changed these formats from mixed numbers and improper fractions, is it's kind of like starting right here, right? Like, hey, that stuff that we just did, it's almost like it never existed. And now we're looking at a problem that is exactly like the ones we were doing last time. What was that, 2.6, I think? The work is still there. Don't worry about that. But, yeah, it's like we were starting right here instead. But now that I have that, now we would look for simplification. And since we're pretty focused on cross simplification, at this, I may do this one twice, but I may wait for a different one. So I would look at this. Now remember, you got to analyze the tops compared to the bottoms, right? So we got 21, 20, 10, and 3. Take your time with this analysis here because simplification is pretty crucial. So we got to look at these numbers and think, well, is there something on the top that I can simplify with the bottom? And simplify means, can I divide a top number by the same number as one of the bottom numbers? I hope I'm wording that okay. But I would look probably first at 20 and 10 right here because they both end in the zeros. And that makes it pretty easy to divide both of these by 10. Okay, and again, that's just a visual check. I see the 0 at the end of both numbers, so I know they can divide by 10. Okay, well, what happens if we divide these by 10? Well, 20 divided by 10 is 2. And then in the bottom left, 10 divided by 10 is 1. And 1's a nice number to work with because later on we're going to need to multiply with this number. 1, as easy as it is to multiply with 10, 1's even easier in my opinion. Okay, well, what about these other numbers? We've got 21 now, 2, 1, and 3. 1's not really something we'd look at. 2 and 3 are no good, but 21 and 3, yes. We can work with these. We can say 21 and 3 are both divisible by 3. So we will. 21 divided by 3 is 7. 3 divided by 3 is another 1 right there. Oh, okay, so we're going to get a fairly unique answer here. So let's set this up because looking at these numbers that are left, I got 7, 2, 1, and 1. Since I'm left with 1s in the denominator only, there's nothing more that we can do to simplify. But what we can do is take these. So in the numerators, I've got 7 and 2, right? We're just going to multiply those. So I have 7 times 2, which is 14 in the numerator. And then in the denominator, we have 1 times 1, which again is very easy to work with. It's just 1. And in fact, with this, so I'm okay with 14 over 1. But remember, on the assignments and on exams, make sure you just simplify that completely. I still think it's completely simplified, but do yourself a favor and make sure you get credit by saying, well, anything over 1 is itself, so make sure you just write it as 14, and we'll call that one good. Now, this is not what I expected. I kind of expected there to be an improper fraction that we would then need to simplify. This one did not. What do you do? Well, that's good. All right, so this multiplication sets up a little different. 2 and 4/5 times 3. And again, we may look at that 3 and think, well, how do you multiply by 3? Well, 3 is a fraction. It just has some phantom numbers, specifically a phantom 1 in this case. You can make it 3 over 1 like this. And that will allow you to do some multiplication as a fraction now. But even before that, I guess, well, after it for me now, I've got the 2 and 4/5, which I need to change into an improper fraction. So I will. I got 2 and 4/5. Again, the denominator is going to stay fifths no matter what I do to this in cycle method or what numbers I get from cycle method. So cycle method, right? We got the first, we'll do the multiplication. 2 times 5. So those 2 whole pizzas would have 10 pieces of pizza. And then you'd add the 4 numerator from whatever is left over of that other pizza, and you'd have 14 pieces. So you got 14 fifth-size pieces of pizza from the 2 and 4/5. Now the 3/1, which I have written, I'm now going to write just as 3/1. Well, that's not bad, just like we had before. No need to use cycle method here because 3/1 is just, it just came from 3, which isn't too bad. But now that I have this, I would look and think, is there anything I can simplify? And I mean, think hard about it. Yeah, some of you guys know what's going on here. But yeah, 14 and 3 and 5 and 1. Again, there's a 1 there. Can I simplify with a 5? I don't see it. I don't see it. So that means we can go directly into the multiplication. And for this one, I'm going to start in the denominator just because it's easier. So 5 times 1 there is going to be, well, 5. But in the numerator, we have 14 times 3, which I do need to do a little work on. So 14 times 3, because this is just right outside our boundary for memorizing multiplication facts. 4 times 3 is going to be 12. Carry the 1. 3 times 1 is 3, but add the 1 would be 4. So it looks like we get 42/5 by multiplying 2 4/3 by 3. And in fact, this may be a good point to say, well, 2 4/5 times 3 is like saying you got 3 sets of 2 4/5 pizzas, I guess. So, or 14/5 pizza, and multiply it by 3, you'd end up with 42/5 right here, okay? Now, this is not our final answer because, I mean, it'd be nice if it could be, but we usually want our answers not in a improper fraction format. So we're going to change it into a mixed number format. And once again, this is not going to change the denominator. So here, where we have fifths, we're going to keep these as fifths as well. And now that we got that, let's go ahead and get into our long division. 42 divided by 5. So again, the quotient will be our whole number, and then the remainder will be our numerator. So 5, it will not go into 4, but it will go into 42 8 times. 8 times 5 means we used up 40 of those pieces. So when I subtract this, I should get a remainder of 2 minus 0 is 2, 4 minus 4 is 0. And so I have both numbers that I need for the mixed number. We've got the 8, and then we've got the remainder of 2. 8 and 2/5. And again, this it really is not, it's not that much work, but it's still enough work for me to make plenty of mistakes in. So if they did not specify like this one, if they did not specify, hey, put your answer as a mixed number, I wouldn't do it, but for the sake of practice, I am. And also, since we don't know how that's going to turn out on an exam or the assignment, I'm gonna keep both up as our answers there. Well, as I said already, and as we've already seen before, we never actually divide fractions, and so we're never gonna divide with mixed numbers either. What we will do is we will take the dividend fraction, we're gonna keep it the same, but we are gonna change the operation from division and change it to multiplication by reciprocating the divisor fraction. So the second fraction is the only one that gets flipped. Again, you may look at this as a keep, change, flip formula, I guess. I don't know. But this is good. We don't want to divide with the fractions. We only want to multiply with them. So we're going to change any division problems we see into multiplication, and we'll go from there. Okay. Now, yes, do remember this always at the end. Look for any simplification in case we missed any while we're doing the cross simplification. And if you're not doing cross simplification, that's okay. But do remember that you should still look for any simplification at the end, because that's where that's a fair amount of mistakes are made there, okay? So, as usual, operating with mixed numbers, we've already seen this slide. Remember, we did not specify the operation. If you have any mixed numbers, change them into improper fractions. Then you do your operation. Last one was multiplication. Now we're going to be looking at division instead. Change your answers back to mixed numbers if they tell us to. Now, they're not going to tell us to, so I'm just going to do it for the sake of practice. But again, on an exam, if they were like, no, they didn't specify, don't do it. Just save yourself this third step, because like I've said, and this is mostly for me, hopefully you guys don't make this kind of mistakes, but it's enough for me to make the small errors. Now, this one is a mixed number divided by a proper fraction, 2/3. It doesn't matter. The process is still the same. We never want to work directly with mixed numbers until we get a little bit more experience. And then also, we don't want to use division. So the process, remember, first is to take your mixed numbers, which right now we're looking at 4 2/5, and we want to change that into an improper fraction. So the improper fraction will keep the denominator, but we'll use cycle method to find the new numerator. So first up, we'd have 4 times 5, which is 20, And then we'll add the 2 numerator to get 22. So that's the same as 22/5. So you had 4 pizzas that were cut into 5th size pieces. You'd have had 20 pieces from the 4 pizzas, plus the extra 2 there in the top. Means you have 22 pieces of pizza that are 5th size pieces of pizza. Now that we have that, let's go and change our operation. No, I don't want to change the operation yet. Let's not do that yet. So I'm going to keep the division, but the 2/3 as well, I'm going to keep that. What the heck? Right? We don't want to change, we can't change the 2/3 into an improper fraction. It's proper. And we can't change it to a mixed number because, well, it's proper. But now that I have this with the improper fraction and the proper fraction, I do want to change the operation from division to multiplication. That'd be good. So again, the dividend fraction stays the same, our 22/5. But what will happen by changing the operation is a flipping of the second fraction. So where it was 2/3, now it will be 3/2. Okay, so again, hopefully this isn't anything new. There is this extra step from multiplication. We did have to do this part right here. But again, nothing else really changes. Even at this point, it'd be like saying, well, what if the problem started right here? Now it's a problem like we saw from 2.6, I think. So again, this should not be considered anything new. We'll keep the work there. But now I look at my 4 numbers. I got 22, 3, 5, and 2. On the top, 22 and 3. On the bottom, 5 and 2. I need to look at these and think, is there something I can divide both the numbers by? Because if not, then we can jump straight into our final product in this case. But there definitely is. I'm looking at the 22 and 2. These are both divisible by 2. Okay, so we need that. 22 divided by 2 is 11. 2 divided by 2 is 1. Now, again, I'm not doing any long division on these because these are within our multiplication facts that hopefully that we have memorized. Now, if you don't have them memorized, you can still use long division and still get the same answers as 11 and 1. And that's okay too. But for now, the 1, again, 1, if I start seeing 1s, I feel pretty good about it. Because when I do need to multiply, I'm multiplying by 1 instead of 2, which 2 is not that hard, but 1's even easier. Now I look at the rest of these numbers. I got 11, 3, 5. Again, I'm not worried about the 1, but 11 and 3, neither of these are divisible by the same number as 5, which 5 is only divisible by 1 in itself. Again, this is the type of analysis you want to do when you're doing cross simplification. Take your time on this so that you can ensure that you're doing the simplification correct. But this looks pretty good. In the numerator, I've got 11 times 3. 11 times 3, which is 33. And then in the denominator, I've got 5 times 1. And 5 times 1 is 5. Again, anything times 1 is itself. It's always nice to be able to multiply by 1 for that exact purpose. Now, that would be okay as the improper fraction. And again, you can relook at this 33/5. Can I simplify this? No, I cannot simplify because we already did the cross simplification back here. But as promised, we are going to make this answer also its mixed number format, or change it back to mixed number format, even though this one did not tell us. This is just for practice purposes. So let's go and take this 33, and we're going to divide it by 5 with long division here. So remember, the quotient is the whole number, and the remainder will be the numerator. So 5 does not go into the 3, but it will go into 33 6 times. 6 times 5 means we use up 30 of the 33, and that would leave us with a remainder of 3. So with that, now we have the whole number, 6, and the remainder of 3. So this is 2 answers that are actually the same value. They're just in the different formats, just in case you need one or the other. That's it right there. And by the way, even though we've changed this into its mixed number format, this is also a good chance to look at just this smaller fraction, the 3 and the 5, and just think, can I simplify these 2 numbers as well? Because if you can, you don't have to worry about the 6, but you look at the 3/5. If that can be simplified, then you would it means you missed some simplification back there. But we did it. This looks pretty good, and so this one's done. So 3 1/4 divided by 2. Take a minute, try this one, then we'll go over it, okay? And if you make any mistakes, that's all right. We're still going to go over it, and it's just practice, so it shouldn't be a big deal. All right, well, let's go through our process. So again, we don't want any mixed numbers out there. So the 3 1/4, it gets changed. And of course, it's not going to affect the denominator, so we'll keep the fourths there. But we got 3 times 4 to start with, which is 12. And then we'll add that numerator 1 for our new numerator of 13. So we have 13/4, and we'll divide this by 2. Now the 2, at this point, if you haven't done so yet, I would make it 2/1, because we need this in its fraction format so that we can change the operation from division into multiplication, which I will now do. Division will become multiplication. Of course, this does not affect our dividend fraction, so the 13/4 stays the same, but it will flip the 2/1 as now 1/2. So, with this, now, I don't see any simplification, right? So that looks pretty good. And let's keep this color coordinated. But in the numerator then, I don't see any simplification. So I've got the 13 times 1, 13, anything times 1 is just itself, is 13. And then in the denominator, 4 times 2 is 8. That looks better, right? Now, again, so the 13/8, again, I would look at this and say, well, I know it can't be simplified. This cannot be simplified. I can't divide by 2. I can't divide by 4. 13 is prime, so 8 is not divisible by 13, of course. But what I would do now is I'd say, well, let's just change this into its mixed number format, just in case they ask for it. And again, that will not affect the denominator of 8. So I'll keep that 8 right there, and then I'll do some long division. So let's go and do 13. I'll do it above there. 13 divided by 8 with some long division, because we love it so much. 8 does not go into 1, but it will go into 13 once. 1 times 8 is 8. So we used up 8 of the 13, which gives us a remainder. 13 minus 8 is 5. So we get the whole number of 1, and then the remainder of 5, 1 5/8. Again, these have exactly the same value. They're just in different formats. And, well, I feel pretty good about saying, oh, that looks pretty good. Okay, so this is, that looks like a little bit more division, but take a shot at this one too. Let's see how you do on this, and then we'll come back and do this one together too. So let's go ahead and take these 2 mixed numbers and change them into improper fractions, which again is never going to affect the denominator. So where this is 4 1/5, I will have still fifths in the end. So again, we're not changing the sizes of the pieces, we're just changing the way it's shown. So I'd start with 4 times 5, and 4 times 5 is 20. And then would add the 1 numerator, which is going to show 21 of the fifths. So there's my first improper fraction. Let's keep the operation. So I'm not changing the operation yet, and I wouldn't recommend that you do that either, because students that try to combine these tend to make mistakes. So please wait to do that. So the second fraction, or mixed number for now, 1 23/40, is going to keep the 40ths denominator. And now we'll do some mixed, some cycle method on this. We got 1 times 40, which again, I don't really need to stack and multiply because anything times 1 is itself. So we get 40, and then we add the 23. I do need to stack and add that though. 0 plus 3 is 3 in the ones place value. 4 plus 2 in the tens place value is 6. So we end up with 63/40. Well, with this, let's take our dividend fraction, 21/5, and we are going to change the operation to multiplication by flipping or reciprocating the divisor fraction. So now, it's going to be flipped as 40/63. Is this okay? Okay, so this is where I'm at right now. And then I would look for any cross simplification that I can do. Of course, you're welcome to multiply these. 21 times 40 is 840, and then 5 times 63, I don't know, 315. I don't really care about that because I don't want to do it. That's a lot of multiplication, and it's going to end up being large numbers that I don't want to really deal with, especially when we get to the long division there. So cross simplification for me on this, I would first look, again, you look at the two top numbers. We got 21 and 40, and then 5 and 63. The 5 is a pretty small number to deal with right there. So I would look at the 5 and think, 5 and 40, I can't simplify the 5 with 21, but I can definitely do it with 40. And again, this is the type of analysis you need to do. Take your time on it, but do plenty of analysis when you're looking at simplifying this stuff. But yes, I see the 5 and 40. I can divide those both by 5. And what do we find? But 5 divided by 5 is 1. And 1's a nice number to deal with because whether we're multiplying or dividing with 1, it's very nice to work with. 40 divided by 5, though, there's going to be 8. So there's that one. And then I'd look at 21 and 63. These are both divisible by 7. Now, by the way, you can go further than that. I'm kind of doing 7 on purpose. But divide by 7, just to make it fairly easy. 21 divided by 7 is 3, and 63 divided by 7 is 9. Now, we look at these numbers, these new numbers, and again, we should just check to see if there's any simplification that can occur. So we can't really do anything with 1 anymore. The 8 is even, but 3 and 9 are not. So we'd have to look specifically at 3 and 9. And yes, those are still divisible by, well, 3. So we need to divide them both by 3 again. Or divide them again, but this time by 3. 3 divided by 3, there's another 1 for us. 9 divided by 3 is 3. And, okay. We got the 1s, and we got an 8 and 3. 8 and 3 are not divisible by anything that's the same. And 1 and 1, once you get down to 1, that's pretty much as low as we can go. So this means we're ready for the multiplication. And we'll start with the numerators of 1 times 8. 1 times 8 is 8. And then in the denominator, 1 times 3 is, well, 3. So that's our improper fraction, 8/3. But just in case we need it, let's take a look at that mixed number, which, as usual, is not going to change the denominator. So it's still going to be in thirds. Well, let's go and do our long division here. It's good practice for us. 8 divided by 3. So let's say, let's see, let's go orange. 3 goes into 8 twice. And 2 times 3. Yeah. 2 times 3 means we used up 6 of the 8. 8 minus 6 is, well, remainder of 2. Now, those 2's are different. The quotient is 2, so that's our whole number. And the remainder of 2 is the numerator. So that's, I don't know, it's good to color code stuff. There we go. That looks pretty good to me. And yeah, once again, I know 8/3 can't be simplified, but I definitely know 2/3 cannot be simplified. So both these are pretty well simplified right there. So I'm going to do the simplification a different way because I forgot to do it last time. But let's go back to where we had 21/5 times 40/63. So I still recommend cross simplification. It's fairly simple. You can look at 2 numbers at a time and be done with it. So if you hate this, get on your phone, go in the hall and take a break or something like that. If you start to hate it and you really like this cross simplification stuff. But this is simplification with prime factorization. So as we know, it's okay to show numbers in a different format, right? Just like we've done here. This 8/3 has exactly the same value as 2 and 2/3, but it's a different format. Not a big deal. So what we do is we take these, well, we take 4 numbers as best we can, and what we end up doing is show them differently. Now the 5, there's not really anything I can do with the 5. The 5 is 5. But what I can do is I can take 21 and split it up into its prime factors. So 21 I would split up, this one's not too bad, 7 and 3. Now if you were like, yeah, but it's 3 and 7, it doesn't matter which order they're in, okay? So I'm going to show this at just how I have it, 7 times 3. Now notice, 7 times 3 is 21. I just changed the format. That's it. I showed it as its prime factorization, and that's all I really need. Now we're going to take the 40 and 63 and change it into the same prime factorization format. So here's my fraction line. I made that fairly long on purpose because you can end up with lots of prime factors. Let's start with the 40, okay? So 40 splits up, I'd probably say 4 and 10. Some of you may have said 8 and 5 or 2 and 20. I don't really care. Just we need two factors, and neither of these are prime, so I'm going to split them up until I get prime factors, like 2 and 2. 4 is 2 and 2. 10 is the same as 2 and 5. Okay? So the 40, which is in the numerator, is going to stay in the numerator, but I'm going to change the format into its prime factors. 2 times 2 times 2 times 5. I think I did enough 2s. But if you did multiply these out, you'd get 40, right? It's the same value, just a different format. Now that may not make sense what the crap we're doing with that. We'll get around to it. Let's do 63 first. So 63, probably should give myself more space there. So let's take 63 and break this one up. So I would think 7 and 9. Okay, so that's a 7 right there, which is prime. 9 breaks up into 3 and 3, and that should be the prime factors for 63. So 63 then becomes 7 times 3 times 3. Prime factorization right there. Now, some of you guys already are like, well, that freaking sucked right there. You don't have to do this. You don't have to do this method. No one is ever going to force you to do this method. In fact, I don't remember seeing it on the assignment. Do you? I don't remember seeing it on the assignment as well. Just so you know, I like this method, even though it's a little bit more work because I'm a math nerd, but not everyone is, you know what I'm saying? So if you like this, then feel free to use it. It's useful anytime, and it does break things down into, I don't know, smaller numbers, which are more manageable. But at this point, we're looking at, just like we did with fractions before, we're just looking for any matches in the numerators and denominators that will divide by each other. So for example, I'm going to start with this 7 over here, okay? I got this 7 over here and this 7. They're matches, which really means that I've got 7 divided by 7, and anything divided by itself is 1 right there, okay? And then, I'd go to this 3 right here. So I'm putting 2 marks on it so I know that it's my second simplification. But I would say that it becomes a 1 with this 3 right here. Yeah, but couldn't you do this 3? Yes, but you can't do both. It doesn't matter which 3 you choose. You just don't do both of them, okay? And then we got a 5. So this one is our third simplification with this 5 right here. Okay, well, that's cool. And it's colorful, so it's pretty. But what do we do with this? Well, we're going to take this and we're going to rewrite it because I don't see any more simplification. I don't see any more matches on the top and bottom. And most students would skip this step. They'd say, well, you got 2 times 2 times 2 in the top. That's all we had left. These 3 2's multiplied together. And in the denominator, you've got this 3, and that's cool. But now you'd say, all right, now you actually have to do that. A little bit more space there. You'd have to actually do that multiplication. So in the numerator, you've got 2 times 2 times 2. I'm going to skip the math there, but that's 8. And then the denominator, you got 3. And now you're at this point. We already know that that simplifies or changes its format into the whole number of 2 2/3. So it's just a different way to get the same answer. But it works. It's a good method. I'm going to do this one too. So I'm going to go back to, let's go back to that. Again, I don't need to redo the cycle method or anything like that. We know we're going to get 14 out of this, but why do we get 14? Well, you got 21 over 10, and we're going to multiply this by 20 over 3. Okay, so just like that last problem, I'm going to change the format into its prime factorization. So I got my red fraction, I got the purple fraction, and these are going to be multiplied together. Now, of these 4 numbers, again, 3 is really nice because it's prime. It's already a prime factor, so I just have that denominator 3. Hey, that's not too bad. But the rest of these can be split up into their prime factors. In fact, I think we already saw 21 split up into 7 and 3, which are both prime. 7 times 3, again, it's 21, it's just changed the format. And then the 10 as well, we'll split this up into 2 and 5. Or, of course, if you'd rather be at 5 and 2, that's fine, but this is how I have it. Okay, now even with this, before I do the 20, you can see that I've got 3's matching on the top and bottom. If you're like, I want to cross those out right now, feel free to do it. But I want to stay on task, because if I start doing too many things, then I tend to make more mistakes, which I'm already prone to. So I'm going to take the 20 and let's split this up. I'd split it up with 4 and 5. Again, some people would say 2 and 10. Doesn't matter. You're going to get the same prime factors. 4 splits up into 2 and 2. So now I end up with 2 times 2 times 5. Now, there's a good point there, because if you stopped, let's say you stopped at something that's not prime, like 4, but maybe you split this, like this one is 2 and 5, you may miss the 2 and 4, because we're looking for matches with the prime factorization. If this is a 4, you may miss the 2's that can be simplified together. We have it, so we're ready now to do some simplification. And this is really essentially the same process as cross simplification, just, you know, shown in a different way. So like I said, we already have this 3 right here on the top in red, and then I got this 3 in purple. The colors don't matter, it's just that they're the same number that matters. And so I've got this 3 and this 3 that match. Now again, I put the 1 mark there so that I can keep track of when and where I simplified. Really, that's 3 divided by 3, which is 1.
Yes.
And since it's multiplied by 1, anything times 1 is itself, so I actually don't have to look at it anymore. In fact, if I wanted to, I could just erase them. But I want to keep the work up here for our own sake. Hopefully it's helping. Okay, then I would scan. I got, I'm scanning. I got a 7. There's no 7's on the bottom. There's a 2. Yep, there's a 2 right there. So my second simplification is with this 2. I'm gonna simplify it with this 2. So again, it's like saying I divided this number by 2 and this number by 2. And that's pretty nice. So there's my second number. Is there any more? I got another 2, but there's no other 2 to match with it. Then I got this 5. Yep, we got a 5. And so a 5 match with this 5 right here. So that's my third simplification, and the 5's are now gone. We don't have to worry about those anymore,
7
too.
and 2 now.
Yeah, that's the only numbers we got left. Now, here's the thing with this, though, is yes, I do have a 7 on the numerator. I do have a 2 also in the numerator, which these are being multiplied. Some confusion can happen at this point, at least in the early stages of this process, while we're getting used to it, just because we don't have the experience. We look and we say, well, there's no numbers here on the bottom, and unfortunately, some students will be like, boom, 0. It's not a 0. It is, there's a number there, it's a 1, okay? It's a phantom 1. You just, see there's a 1 here, there's 1s all over the place in this problem, you just can't see them. They're phantom 1s, they're hiding, lurking in the shadows, constantly watching, always watching, but never being able to be seen. So on this one, we're actually gonna show it with this one right here. In fact, we did show these ones. We had all these ones right here that we did when we're crossing this stuff out with the simplification. But of course, we now have something over 1, and 7 times 2, well, last time I checked, that's 14, and then we would simplify that back over here to just 14, not 14 over 1. So that is simplification with prime factorization, but again, you never have to actually use a specific method. So I don't think I'll ever show this again unless you guys request it. For the most part, I stick with cross simplification. So if you ever want this in the future, you have to ask for it, okay? Well, that concludes 2.8 then. We hit up all 3 of these objectives. So now we can move on to 2.9.